What's up guys, and welcome to another video about Jetpack Compose and Canvas. In this video I'm going to show you how you can build such a beautiful pie chart which displays different list items with different values, and when you click on this pie chart, for example on this segment, then you can see you get the corresponding value, the total value, and also the description. And then you can click on it again and invoke another one like this. And another possibility is to click in the middle of the pie chart, and then all the items get displayed. And you can also set some kind of text in the middle of the pie chart which describes your pie chart. Alright, okay, I'm in an empty Jetpack Compose project. The only thing I did was to add these colors, but you can find them in my GitHub's repository or simply choose your own ones for the pie chart for the different segments. And in here, in our main activity, we are going to remove this default stuff. And the first thing we want to do is to create a data class which represents our pie chart elements. So pie chart input. One input will have a color and a value of type int, a description of type string, and a value if the pie chart is currently tabbed, and this is set to false by default. Then we can start defining our pie chart composable, which we will simply call pie chart. This takes a modifier and a radius of type load, which is set to 500 by default, so how big our pie chart will be. But you can pass another value, of course, into this composable to choose another size. Then we have an inner radius, which is the inner circle of the pie chart, the white one. And this is also of type float and set to 250 by default. I've experienced that it looks kind of good if this is half the value of our radius. Then we have a transparent width, so the little transparent circle between our actual pie chart and the inner circle. And this is of type float and 70 by default. Then we have the input of our pie chart, which is a list of pie chart input. And we have a center text, so a text inside our pie chart in the middle, which is set to nothing by default. So it's up to you if you pass some text or if you leave this empty. I will also quickly copy and paste some default compose stuff here to invoke our pie chart so that we can run our previews sometimes and always see what's currently going on. Otherwise, it wouldn't be that easy to follow, and I think this should help when watching the video. I will go quickly over this, and you can find this code in my GitHub repository and can also just copy and paste it. We have a column as the root composable, which sets some alignment and arrangement stuff, fills the max size. Then we have a text composable inside this column, which tells us what's the screen about. It's about preferred programming languages in my case. And then we have a box which also fills the max size, and in here our pie chart gets invoked. And the pie chart's radius will be 500f. I think we don't need to set it here because this is the default value anyway. And then we have a modifier which also set to 500 dp, and our input list here with different pie chart elements like Python, Swift, JavaScript, Java, and so on. Just some pie chart elements here. And then also the center text where we display that 150 persons were asked about their preferred programming language. Okay, all right, now we can start in our pie chart composable. We first need to declare some mutable state variables. So on the one hand, we have the circle center by remember, which is set to mutable state of and offset.0 by default. And then we also have the input list by remember. And this is by remember because we need to change the input list inside our pie chart composable because of the is tabbed property, if the pie chart element is tabbed or not, or if all pie chart elements are tabbed or not. And this is why we make this mutable state var. And this will be set to our input list by default. Then we have is center tabbed property. So this is a general property if the user actually taps the center, and then we can display all the different pie chart elements properties. This is also by remember and set to false by default. Then we will have a box which takes our passed modifier. The content alignment will be alignment.center, And in this box, we can then start with our canvas. This canvas also takes a modifier which fills the max size, and also takes a pointer input modifier for our tap detection later, but we will first draw the pie chart and care about tap gestures and taps of the user later. In here we will now have different values which interact with each other, and this will be a lot of values. So if this may be too complicated and I can't explain everything in detail, then leave a comment down below in the video, or write me a message or something. And yeah, otherwise the video would be too long. We have the first value, which is our width, which we can get from our canvas. Then we also need the height. And then we have the circle center, which we can get from our width and height. So this will be an offset. The x value will be our width divided by 2f, and the y value will be our height divided by 2f. Then we will also have a total value of our input array. So each item of our array has a different value, and all of the values summed up is our total value. So we say input sum of, and for the value we just take our it.value, so it sums up the whole values of all input list elements. Then we need the angel per value, which we can get from 360 divided by our total value, because a circle has 360 degrees and our total value are all elements summed up, or all values summed up, so we can get the angel per value, which makes drawing easier later. Then we also need a variable current start angel, which is of course 0 degrees at the beginning. Then we go over our input list. We can say input list for each, and then we get the pie chart input in our for each block here. In here, we first have a look at the isTapped property of our pie chart input, and depending on that, we will set a different scale, because if the user taps on a pie chart element, then it scales out. So we can say if pie chart input dot isTapped, we set this scale value to 1.1f and else to 1.0f. After that, we also need the angel to draw, and we can get this from our pie chart input dot value multiplied with the angel per value. And then we know how far we should draw for one pie chart input element. And then we can scale this with our scale value, and if the scale value is just 1.0f, then nothing happens, and if the element is tapped, then it scales out a little bit. Now we can draw the arc for our element, and for the color we pass our pie chart input dot color. For the start angel we say current start angel. The sweep angel will be the angel to draw, and then we also use the center. The size will be width radius multiplied with 2f, and the height will be radius multiplied with 2f as well. And then we also need to set the top left property, which will be our width minus radius multiplied with 2f divided by 2f, and for the height, and the same thing for the height, minus radius multiplied with 2f divided by 2f. And then the last thing we need to do is to update our current start angel and say current start angel is equal to current start angel plus our angel to draw, so that we go a step further to the next item. Now we can already have a look at how it looks on our emulator. And yeah, okay, this looks fine so far, and we draw each item with the corresponding space, and yeah, now things will get even more interesting. Below our for each loop, we can then draw our inner circle and the little circle which is transparent around the inner circle. We can say draw context.canvas.native.canvas.apply, because we want to add a little shadow here, and this is easier on the native canvas and not on the Compose one. So we will say draw circle, and we will pass the circle center.x, circle center.y, and for the size our inner radius. And then we also pass a paint here and say paint.apply. For the color we say white.copy, because we want to make sure that a little bit of the background is shown. So we set the alpha to 0.6f and then to RGB. And for the set shadow layer, we pass 10F, 0F, 0F, and the color gray to RGB like this. And then we can also draw the little transparent circle around our inner circle, and then we can launch it again. Draw a circle, and for the color we say white.copy, and for the alpha 0.2f, so that it is really transparent and we only see a little bit of it. And then for the radius, we will pass our inner radius plus transparent width divided by 2f. So it is around our inner radius and starts to draw around our inner circle. And let me quickly think about, let's also add the text in the center. Then this is also done. We can say text, and for the text we say the center text. So this is about the text inside our inner circle, which tells the user some additional information about the pie chart. This text will take a modifier, and this modifier's width is from dp, our inner radius. So it's dependent on our inner radius, how big this radius is, divided by 1.5f. And it also has a little padding of 25 dp. And then we have a font weight dot semi-bold. The font size will be 70 sp, and the text align will be text align.center. And of course, you can also use your own values and padding and all that stuff. This is just an example here. And yeah, okay, as you can see, this looks quite good so far. Our inner circle and the transparent circle around it, and also the text in the middle. And yeah, okay, now things will get a little bit more complicated because we need to rotate the text, we need to rotate the percentage values and all that stuff, and also make this whole thing clickable. So yeah, okay, now the easy part is done and it will get complicated now. Up here inside our for each loop, after we updated this current start angel, we now need to take care of the rotation logic. First, we say var rotate angel is equal to current start angel. And let me quickly close this. Current start angel minus angel to draw divided by 2f minus 90f. And again, sorry, I can't explain all the different values we have here. I try to explain as much as possible, but if I would explain every value, every variable, then this video would last an hour. And yeah, you just need to know that this is about the rotation now, because we want to display the different percentage texts, and we also need to rotate them, otherwise they would all be shown horizontally. And so that depending on where the text is shown, it rotates a little bit. Then we have a factor, and this factor is for the texts at the top and the bottom, because if the angel is too high, then the text gets stands by the head. So we also need to turn it around, and in some cases. And then we can say if rotate angel is bigger than 90f, this is the case where the text is in the wrong direction. Then we say rotate angel is equal to rotate angel plus 180 modulo 360f, and this just maps the angel to the angel we need. And then we can say factor is equal to minus 0.92f. This is also because the text is inverted then, and we don't want to make this 1f minus 1f, because then we had a different distance between the pie chart and the text. Then we have val percentage, and we get the percentage value of each pie chart input element of the value divided by the total value to float, and multiply this with 100, and then we just convert this to an integer. And then we have the percentage. If you want to have comma separated comma percentage, which is more precise, then feel free to do this. I'm happy with the integer percentage. And then we can say draw context dot canvas dot native canvas dot apply again, because we need to draw text, and As far as I know, there's no solution in Compose Canvas, so we use the native canvas again. If our percentage value is greater than 3, because if this would be smaller than 3, then I think the user couldn't read the percentage value anymore. So we only show the percentage value if the percentage is actually over 3 or greater than 3. Then we say rotate, and we rotate this with our rotation angel, and then we draw a text here. And this text will be our percentage, and we also apply a percentage sign here. Then circle center.x, circle center.y, and for the y we need to add additional values because we wanna set or we wanna draw this percentage value where the user actually can see it in our pie chart where the colors are, not in the inner circle. So we need to add additional value. We say radius minus inner radius, and this divided by 2f, multiplied with our factor. And last but not least, a paint. For the paint.apply, we say text size is equal to 13sp.2pixel. The text align will be paint.align.center, and the color will be white.2RGB. And then we can actually start this, and you can see how it looks now. And yeah, this looks fine, as you can see. The percentage values are drawn nicely. All right, okay, this is it for the drawing. At least the pie chart drawing, not the elements description, which comes when the user taps on an item. But for the pie chart itself, it is it now. And yeah, now we will come to the tapping logic, which will be the most complicated one. And down here below our where we are now below the draw context in our for loop, we can then say if pie chart input dot is tapped. In here we then need the tap rotation, because if the user taps on an item, then it gets scaled out, and we also want to show on the left and on the right the lines which kind of separate the elements so that the user can really see it currently popping out. And for that we can say current start angel minus angel to draw minus 90f. And then we say rotate, and rotate this with our tap rotation. Then we draw a rounded rect, and the top left for this rounded rect will be our circle center. The size will be of type size, and the width will be 12f, and the height will be our radius multiplied with 1.2f. The color will be gray, and the corner radius will be corner radius, and for the x and the y value we pass 15f. And then we need the next line. This is the line on the left or on the right, depending on where you look at it or which element it means. We can say this is the line for one side, and then we also need the other side, which we will get from our rotate, our tap rotation, multiplied with the angel to draw. Then we are at the end of our segment and can draw the next line. Then we can just copy and paste this here, and yeah, like this. And the last thing is our description text, which means in our case the different programming languages like Java, Kotlin, Swift and all that different programming language, that they get also displayed if the user taps on a segment. And also we need to rotate this because we don't want to show it horizontally. And this is why we need this rotate function one more time. This time we again use the rotate angel and not the tap rotation, because the rotate angel means the rotation in the center of a segment, and these two rotation functions here were for the start and the ending of our segment. And then we say draw context dot canvas dot native canvas dot apply, because we again draw a text. And then we say draw text. For the text we pass our pie chart input dot description, and then double colon our pie chart input dot value. Then we set our circle center dot x and circle center dot y for the positioning, and for the y we need to add the radius multiplied with 1.3f multiplied with our factor again, because we want to display the text outside of the pie chart and not in the middle or in the color section. We want to multiply this radius with 1.3f because then the text gets drawn outside. And this factor is again because as in some cases the text is inverted, and then we just need to turn it around. And then we pass also a paint again. Say paint.apply. The text size will be 22sp.2 pixel. The text align will be again paint.align.center. The color will be white.2RGB, and we also set is fake bold text to true. Alright, this is it for all the canvas drawing stuff. Now things will get wild when we detect the tabs and process the tabs of the user to make this an interactive pie chart. Up here in our modifier pointer input, here we will start with detect tab gestures, and in here we define the onTap method. And this onTap method provides us an offset where the user actually tapped. In this onTap method, we now need the angel in degrees where the user actually tapped, because when we have a circle, then it's easier to calculate with degrees rather than with such an offset. And I will quickly copy and paste the formula here, which I already explained in my circular progress slider video, where we do the drag logic. And yeah, this is why I will go quickly over this. You can just copy and paste this as well, or you can also, if you're interested in the details, have a look at the circular progress draggable slider. And this formula will provide us the tap angel in degrees. And now we also need to check if the user actually tapped inside the inner circle. So we will expand all the different items, or if the user just tapped on the outer circle and we only show this specific item he tapped on. And there are 4 different possibilities where he can click and where we need to consider the offset differentially. And this is also a little bit confusing, and it would take like 10 minutes here, I think, to explain this. I will also just copy and paste this. Sorry for that, but yeah, this is the calculation which detects if the center, so the inner circle, is actually clicked or if the click was outside and not in the inner circle. Now we can check on this center clicked value, which should be true if the user actually tapped inside the inner circle. We can say if center clicked, and in here we can then set all the input lists elements, so all our pie chart elements, property is tapped to true or to false, depending on if they are already true. We can say input list is equal to input list.map. And now you can see why we made this input list mutable state, because we need to update it in case the user clicks in the middle or on a specific item. We can here say it.copy, and then we set is tapped is equal to not equal is center tapped. So if it's currently is the center not tapped at the moment, then this is tapped will be set to true, and in case the is center tapped is true, then they are all gonna set to false. This was the easy part, and I think we can already launch the app and check on the center clicks. The last thing we need in this if statement is we need to set this is center tapped, of course, to is not center tapped. And then we can start it. And as you can see, this works perfectly fine. But if we tip, I don't know if you see my mouse. No, I don't think so. But I'm clicking on the outside on the single items, and there nothing happens. Only the center logic works so far. In our else case, which means that the user tapped on the pie chart, but not in the middle of it, we first need the angel per value. And we can get the angel per value by 360f. So 360 degrees divided by input dot sum of it dot value. So 360f, 360 degrees divided by the total values of all items in our list. Then we also need the current angel, which is equal to 0f. And then we go over our input lists. We say input list dot for each, and here we get the pie chart input. We need to do this because we want to calculate on which specific item the user actually clicked, so that we can only show this specific item. First of all, we update the current angel with our pie chart input dot value multiplied with the angel per value. So to this current angel, the additional angel of our pie chart input gets added. And then we can say if tab angel in decrease, this is the angel where the user actually clicked, is less than our current angel. Then we know that the user tapped on this specific item. Because if the tab angel in decrease is below the current angel and the current angel is the highest angel, the end angel of our drawn color of our element, then we know that he actually tapped on this specific item. Then we need the description of this pie chart input element. So val description is equal to pie chart input dot description. And then we can say input list is equal to input list dot map, and check if the description is equal to it dot description, so the element of this input list. And if this is the case, then we detected our clicked element and can update it. It dot copy, and for the is tapped, we simply say not it dot is tapped. And else we just say it dot copy is tapped is equal to false. And if we are in this case, we don't want to go further in this for each loop, and we can just say return and add the text gestures. So this breaks the for loop. All right, I think we can start and try it out. And I enabled my mouse so that you can see where I am actually clicking. When I click in the middle, oh, then everything looks almost fine. We have two lines which shouldn't be there. And let me quickly try the single clicks. Yeah, the single clicks also working fine, but the separator lines are not drawn where they actually should. I need to look into this, but yeah, most of the functionality is working fine, I think. Okay, 1 minute later, I already found it out. Here in our rotate function, I multiply the tab rotation with the angel to draw, and this of course needs to be a plus sign here. We need to add the angel to draw to our tab rotation. Let's try it again. Yeah, now everything works. The separator lines are looking very good, and yeah, also the single item clicks here, and oh, there's another separator line missing here and another bug, and I think this just happens on this first item here. Okay, this is because the separator line gets overdrawn, and this only happens when the first item is drawn, because then the last item overdraws the first item, and the other separator lines in the middle items are not affected by this because they get drawn on the elements color. We can fix this by drawing this single separator line in case the first item is selected above or on top of the drawn last item, and therefore we need to leave the for loop, and we go over this draw canvas here, where actually the circle for the center gets drawn. We can here say if input list dot first is tapped, if the first item is tapped, then we can rotate this with 90F and draw our rounded rect. I think we can just copy it from above and paste it down below and start this again, and then this should work. When we tap on the first item now, then everything works regarding the separator lines, and also of course the text display and all that stuff. Alright, okay, this was it for this video and for the pie chart in Jetpack Compose with Canvas. Sorry about not going into the deep details all the time. I think the video would be just too long, and if you have any questions about different calculations and regarding this code, then I would be really happy to help you. And if not, we will see us in the next video.